questions?
What time is the final at? 9? 9? Because it says 9 through 11. To be fair, it says 9 through 11. So that could start at any time.
You have up until 11 a.m. to finish it.
Okay,
you can come and start whenever you want.
Okay.
But I'm collecting them at 11 a.m. The reason I put that there is because it's so you understand it's a 2-hour block.
Oh.
So because normally our classes are an hour long, but final schedules allow for 2-hour blocks for finals. So, no, I put that on there just so people don't plan something at like 10:15.
Oh, okay.
You know, because it's a 2-hour slot, so you want to make sure you give yourself the full 2 hours.
I got you.
Okay. Kids are killing me.
It's in the air today.
There's something going on, yeah, I don't know. It's all good. All right. So, anywho, I gave you a bunch of equations to practice with yesterday. I have some more. We're going to spend today also just looking at some more examples of equations. There were a few on that sheet that were a little tricky, I think, are ones that weren't quite like examples we went over. So I don't know if you want me to go through all of them or if there's if you just want to tell me which ones you want to go through. You just go through all of them? I don't think. All right, I'll just go through them and then you just stop me and ask questions. Okay, so the first one was pretty straightforward. So it was p plus 2.4 equals negative 9.3. So this one's just a one-step equation. So to get rid of the plus 2.4, we just take away 2.4 from both sides, right? And then you'd be left with p on this side. And over here, negative 9.3, you're already negative. You're subtracting 2.4, so you're going more negative. So negative 11.7 for that one. Okay. The next one involves some combining like terms. So we have a negative 6x minus 11 plus 7x minus 5 equals negative 16. All right. Now, this is something that you don't have to do, but my recommendation is every time you do something in the equation, you rewrite the entire equation on the line right underneath it, because it's really easy to lose terms. So here, we've got some like terms that we need to combine first. So we got a negative 6x and a 7x. Well, what's that going to leave us with? Just one x. And then you've got a minus 11, minus 15, so you're minus 11, minus 15. That's going to take you back to minus 16. Yeah? Okay? And now I'm trying to get my x alone, so what should I do with this 16? Add it over to the other side, and then what happens? X equals 0. All right. So collect like terms, then send all your variable terms to one side, all your numbers to the other one. In this case, we only had x's on the left-hand side, so we just sent all our numbers to the right-hand side. Let's see. Next was 8 times. So this one has some parentheses in it, and so that means we need to get rid of those first before we can complete this. So here, the first set of parentheses we're going to have to get rid of by using the distributive property. So 8 times 4 is 32. 8 times, yeah, that's your next term. Then 8 times 5 is 40. Here, there's just one term inside, but we need to multiply the negative 5 by the 6. So this is a negative 5 times a positive 6x minus 30x minus x. All right. And now we've got a whole bunch of like terms that we need to put together. So we got 32x minus 30x. That'd be 2x minus another x. What's going to be left with? You're just going to be left with an x when you combine those. And then you can just finish this off by doing what? Take away 40 from both sides. And so your answer would be x equals 13. All right. Again, just stop me with questions when you need to ask. Okay. All right, so those ones, all of those, notice that we just ended up with just like a p or an x or an x. They didn't have any division that you had to do at the ends. But if that happens where you end up with a coefficient or a number attached to your term after you simplify, that's okay. So like the next one, 6x minus 2 equals 40. First thing we do is what? We'd send that 2 over to the other side. And so we'd just be left with 6x on this side. 40 plus 2 is 42. If you come in a situation like this where the number's attached to the x, well, how do you get rid of it? you would divide it out because it's 6 times x, and so you just get 7. Okay? All right, so all your variable terms to one side, all your numbers to the other side, and then at the very last step, you may have to divide to get rid of that coefficient. All good? All right, let's look at some other ones. How about 25 equals negative 9y plus 7? Okay. What would you do? Yeah, so since we've already just got one y term on the right-hand side, even though it's negative, I'm probably just going to leave it there because there's no reason in moving it since it's already on its own. So 25 minus 7 is 18, right? And you just have a negative 9y left there. Now to get rid of it, what do you want to do? Divide, and you want to divide it out with the sign because you only want a positive y left on that side. So you want to make sure when you divide it the negative with a 9. And then 18 divided by negative 9 is negative 2. All right. So then next we got, this one is the first one where we see the variable happening on both sides of the equation. And so we've got an x on the left and x on the right. So what do we got to do? We got to move one of those terms over, right? So which way would you move it? Would you send the 5x to the left-hand side or the 6x to the right-hand side? Yeah, I would probably just move the 5x over to the left. And that's going to keep my x terms positive. It doesn't matter which way you do it. So I would take away 5x from both sides. And so you just be left 6x minus 5x is just x. And then you're just left with a 3 on that side. Then you can add your 15 to both sides. And so you got x equals 18. Okay? All right. So again, just stop me if you have questions. Okay. All right. What came next? The 8y one? So you got 8y minus 30 equals negative 2y plus 30. So again, you can send your y's to either side. I would probably take my negative 2y on the right-hand side and send it over to the left-hand side. So say, all right, so we got, I would send 2y over here, plus 2y plus 2y. So you'd end up with 10y minus 30 equals 30. Then we just get rid of that 30, so we got a minus 30 over here I want to send over there, so I'd add 30 both sides. And then you got 10y and 60. So last step would be divide by 10. And so y is 60 divided by 10 is 6. Any questions on any of those ones on the board right now? You still okay with that? Didn't lose anywhere? Perfect. All right, now it gets trickier. So I'm going to put up a new one for this because there's a couple ways you can deal with a problem like this one with fractions. So the problem is 5/4 c minus 3 equals 1/4 c minus 16. Okay, so this one, you can just solve it like normal, leaving all the fractions there. So, like, did anybody finish this one? Did anybody actually do this one? Anybody? Okay. So, you could just have the same strategy and just say, okay, well, I would just take away 1/4 c from this side, right? And then you got 5/4 minus 1/4, so what is that? 4/4 c. But what is 4/4? 4/4 is just 1, right? So this one actually kind of works out nicely because when you take away the 1/4, it just becomes a c, and then you can finish this one off by just adding 3, and so you'd get c equals, it looks like, a negative 13. That's one way you can do it, and you can just deal with the fractions. Now, the thing is This one happened to be really nice because the fractions had common denominators and they combined to a nice whole number, which is convenient, but it's not always necessarily the case. Okay, so another way that you can solve problems like this is a process called clearing fractions. Okay, and what you do is you multiply everything by the least common denominator of whatever fractions are in your expression. So I'll show you. So in this one, it started out as what? 5/4 c minus 3 equals 1/4 c minus 16. Okay. So what we could do here is we could say, all right, I see some fractions in my equation, and they all have a denominator of 4, right? So the LCD is 4. So what we do is we say, okay, then I'm going to multiply this side by 4, and I'm going to multiply that side by 4. And you can do that in equation because whatever you do to the left-hand side, you can do as long as you do the same thing to the right-hand side. Now, what we would do then is to multiply that 4, we need to distribute it to all the terms. Okay. Now, what happens when you multiply the 4 times the 5/4? The 4s are actually going to cancel out, right? And it's just going to be left with what? 5c. Yeah. Another way to think of it is 4 times 5 is 20. 20 divided by 4 is 5, right? So the 4s cancel. So this is going to become a 5c. 4 times negative 3 is negative 12. Okay. Same thing on the other side. What's going to happen there? Well, 4 times 1 is 4 divided by 4 is 1, so that's going to be c. And then 6 times negative 16 is what? Negative 64. So what happens is that if you multiply by the least common denominator, you turn it into an equation without fractions. So now our fractions are gone. And we can just solve it like a regular equation using the strategies that we've already been using. So then we could bring this c to this side, so you'd have 4c minus 12 equals negative 64. Then you could add 12 to both sides, and you'd get 4c equals, what's that, negative 52. And then you could divide both sides by 4, and you'd get the answer negative 13. So it's like in this case, you know, it wasn't too bad to do it with the fractions. This one wasn't so terrible. But I have some over here on the next worksheet where you might end up with an equation that have unlike denominators, and in that case, it's a good idea to clear fractions, but you can just work with whole numbers. I'll show you another example of that here in a few minutes too. Okay. Any questions on that one? Either way that I solved it. Okay. So then we had this negative 4 times 2n plus 1 equals 16. Right, so we'll solve that. So negative 4 gets distributed. That would be negative 8n minus 4 when you distribute that through. Okay, so now what should we do? Get the 4 over to the other side. Yep, by adding 4 to both sides. So you got a negative 8n. 16 plus 4 is 20. And then our last step would be, okay. Now here's the thing. If you get to a situation where the numbers aren't divisible, though, you could turn that into a decimal, but then you might end up with a decimal that doesn't terminate or whatever. So we really want to leave these as fractions. Unless the equation started with decimals, then your solutions should really always be fractions if they pop up. So like here, 20 divided by 8. So 20 divided by so positive divided by a negative is negative. So our answer is negative 28, but we should reduce that because 20 and 8 are both divisible by what? Like 4? At least, right? So then 20 divided by 4 is 5, and 8 divided by 4 is 2. So the best answer to this problem would be negative 5/2. Yeah, so this is also negative 2.5, which is negative 2.5. But you should be able to solve this problem, and this isn't wrong, really. But you should be able to solve this problem and come up with that answer if you had to. like I put, like if I put maybe there's a multiple choice problem or something, I might not put these two options on there, but I might put that option as an answer. And it is an answer. So you want to be comfortable leaving your solutions in fraction form, and we don't always want to convert to decimals, especially if the decimals are like repeating or never ending. So, all right, questions on that one? Okay. And then the last one, well, we got 11 minus 4 times y minus 8 equals 43. So what? We got to put that minus 4 through. So that would be 11 minus 4y minus 4 times minus 8. Positive 32, I think. Okay. And then combine like terms. So you got this minus 4y. And then we got 32 and 11. So that's, what's that come out to be? 43? Okay. So then when you take away the 43 from both sides, you get negative 4y equals 0, which means it looks like y is just 0. Okay. What do you think?
Would you take points off if you don't do it exactly that way?
Not if you get the right answer.
Okay.
Yeah, because there's no right. I mean, there's multiple ways to solve these problems. Yeah, it's not one path. There's many paths.
Yeah.
So, other questions about any of those? Because I want to show you some example. I want to show you an example where you would want to clear fractions with non-like denominators, and it might make your life a lot easier. All right. So let's do one. So another example of clearing fractions. So let's say, for example, you had that equation like 1/2 x plus 1/3 equals, say, 2x minus 5/6. I mean, there's no reason that equation can't exist. Okay, so then how would you solve this equation? Because right now it's just like chock full of fractions. And so it'd be a really big pain to try to solve this thing while leaving all those things in fractions. That's where the least common denominator comes in and helps us out. So what is the least common denominator? You look at all the fractions. What's the least common denominator of all of them? For all those fractions? 6, right? So then what we do is we say, okay, I'm going to give everything on this side of 6, and I'm going to give everything on this side of 6. All right. Then it gets a little trickier. You just have to remember how to multiply whole numbers times fractions. So how do you multiply 6 times 1/2, right? That's 6 times 1 over 2. So 6 times 1 is 6, divided by 2 is, so that's going to become a 3x, right? Okay. Then we go here, 6 times 1 is 6, divided by 3 is 2. Yeah? All right. Then on this side, just 2x times 6 is just what? That was just 12x, right? And then here, you've got 6 times 5 over 6. Well, the 6's just cancel. Oops, I didn't mean to write that there. Let's write it underneath it. It's the 6's just cancel. Or 5 times 6 is 30 divided by 6, which gives us a 5. Okay. Makes it more confusing. So the point is that what started as kind of a complicated equation with a lot of fractions in them, when you put that LCD through, what you come out with at the end is a really nice equation with all whole numbers and nothing else. So, okay? All right, so now how would you solve this? First we need to do what? We need to bring our terms all to the same side, right? Yeah? So I would probably pull my x term. Which way would you go? Yeah, I would probably subtract 3x from both sides, send that 3x over to the right-hand side so that they stay positive. So I'd have a 2 on that side. 12x minus 3x is 11x. And then maybe add 5 to both sides. And so you'd end up with 7 equals 11x. And then your last step would be divide by 11. So then the answer would be x is equal to 7/11. All right. What questions do you have on that one? Any questions? Okay.
Isn't it 9? Yeah, isn't it 9?
Oh yeah, yeah. So 12x minus 3x should be 9x. 9x divided by 9. 9. There you go. All right. Any other questions? Okay. You can actually do something similar with decimals. So I'll write this over here so some of you guys are still there, I think. But if you want to clear decimals, so let's say you had like 0.4x minus 3.1 equals, say, like 0.6x or something like that. I don't know. Now let's say 0.5x. Just for the sake of this. Okay. You could solve this just using decimals and leave everything in decimal notation. But like with least common denominators, we could just basically move that decimal point on all these values. Essentially what we're going to do is we're just multiplying everything by 10. So you could actually just move that decimal place as many place values as you want to the left or the right, as long as you do it to all the terms. Just like we can multiply the LCD into everything as long as we did it for every term. So you could actually just move everything over one decimal place, and that would become 4x minus 31 equals 5x. And so then that makes everything nice and easy to work with. So then, well, you could solve this so you could bring that 4x now to this side, and so you'd be left with negative 31 equals, well, 5x minus 4x is just x. Yeah. Could. If you put it in a fraction and then you do what Dewey just did, you would just end up multiplying everything by 10, and then you'd end up back at that equation. You could do it without the you can do it with the decimals. So back at this point, you could actually subtract 0.4x from both sides, and you'd get negative 3.1 equals 0.1x, and then you could divide both sides by 0.1, and then if you plug that in your calculator, you'll get the same answer. So you can solve decimal equations without getting rid of the decimals. It's possible, but a lot of people just really feel a lot more comfortable working with whole numbers. And so if you run into an equation with lots of decimals or fractions, clearing those out just makes it a lot easier for a lot of students. But it's optional, it's not required. Okay? How are we all feeling today? A little lethargic. Is it Thursday?
Yeah.
Thank goodness. That's great. Okay, I forgot about that. Okay, so I got some practice problems for you. These are just some more equations, but these ones can include some decimals and fractions so that you can kind of have some more practice with those. And then I will see you all on, if you don't stick around now, I will see you on Monday.
Because I was sick yesterday and I kind of forgot too.
Well, there's a lot of them, and I drop your lowest one anyways. So if it goes in as a 0, it'll just get dropped automatically because I dropped the lowest. Yeah. So missing one isn't gonna like really affect. Missing just one, as long as you just miss one of the homework quizzes, then it doesn't really.
Yeah, because I missed the one from yesterday.
Yeah.
Like, since I didn't come to class, I forgot. So.
Yeah, it won't. It'll get dropped.
Oh, okay. Sounds good. Thank you.
Oh, okay. I was like,
You want to use the 4 to get rid of all that. Yeah. So this is 4
well, maybe I'll get it done.
Yeah.
I'm good.
I use humor as a default.
Always, yeah. So that's like everything. You're trying to you're trying to bring everything up to fourths. So you're trying to get like, and that's what you have an expression. That's what you have to do. When you're trying to add, like you're trying to add fractions that have non-like denominators. You have to have a common denominator to do that.
Yeah.
That's true. Yeah. But since you have an equation where you have some stuff on the left-hand side and stuff on the right-hand side, we can get around that problem by just giving everything the least common denominator. So we're basically scaling the whole equation up so that we don't have to deal with fractions. So I know what you're thinking.
Yeah, I am.
But since it's an equation,
Yes.
if it's an equation, so equal sign, if you see that equal sign, you don't have to deal with fractions at all. You can get rid of them. All right. Everything needs a 4. Was she talking to me? Did she say something to me? Or was she talking to you? Oh, Jennifer was saying to me that she checked her email. Oh, okay. Perfect. Okay, so everything's going to get a 4. Boom, boom, everything. Because what happens is, this is, so 4 times 1 is 4. So when I give it to my first one, what do you do? 4 times 1 is 4, divided by 4. So it's just y. Yeah, 1y. Okay. So what about the next one? Yes. So plus. $28, yep. Then what happens here? So on the other side, 4 times is 12. 12 divided by 4 is 3. So you're just going to be left with 3y. And then 4 times minus 3 is Yeah, and then you're just solving that equation. So then you can forget about the fractions, and you can just work from here. Now just pretend like this is where our problem started and just work from there. I'm gonna stop my recording real quick.